What do you mean by notch? My voice is audible?
Edge, ma'am. Edge.
What do you mean by notch? Which material you are going to use for construction of notch? Which material you are going to use to construct a notch?
Masonry or concrete, ma'am.
Yes. Just tell me which material you are going to use. Yesterday itself, I said the difference between notches and weirs.
And for construction, ma'am.
I'm asking, what do you mean by notch? That's it. What do you mean by notch? At least tell me why you are going to use the notch. Yes, answer me.
Measuring the
Why
discharge,
you
ma'am.
are going to use? Yes,
For measuring discharge, ma'am.
for measuring discharge. Which material is used here to construct notch?
Concrete or brick masonry, ma'am.
No, no, no. I'm talking about notches. So, is the screen visible? Screen is
Yes,
visible to
ma'am.
you?
Yes, ma'am.
Yes, ma'am.
So here you can see this is a notch. So this is nothing but it is a notch. How it is looking like?
V shape, ma'am.
No, which material it is? It is a triangular notch. Which material it is? Which material it
Steel.
is? It is a thin metallic plate. Okay, so this metallic plate, it is very thin. So this metallic plate, we are going to fix at the end of the canal or a channel. Excuse me. Hello? 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 Hello, everyone there?
Yes, ma'am.
Yes, ma'am.
Is my voice clear or is there any disturbance?
No, ma'am. Clear, ma'am.
Now, if there is any disturbance, then you can tell me.
Yes, ma'am. Some disturbance is there.
Disturbance, ma'am.
Uh, Kindly wait for 5 minutes. So, be online. Don't exit. I will continue the class after 5 minutes. Okay, fine. So this is the triangular notch. So depending upon the shape, we are going to classify the notches into triangular, rectangular, trapezoidal. Hmm. Other reset model. Reset. So So depending upon the shape, the notches are divided into triangular, rectangular, trapezoidal, and stepped.
Screen is not visible, ma'am.
Hello, am I audible to you all? Hello, hello,
Ma'am.
hello. Am I audible to you all?
Yes, ma'am.
Yes, ma'am.
And there is an electrical fluctuation over here. So I will take the class at 2 o'clock. Okay. So you're having any class at 2 o'clock?
M3,
Hello.
ma'am. 2:30.
Here there is a disturbance. 2:32.
4:30, ma'am.
Okay. Just a minute. Just a minute. Wait for 5 minutes.
2:30 to 3:30, ma'am.
Okay. So these are the different type of notches depending upon the shape. So this is a triangular notch. So the notch is nothing but it is a thin metallic plate which is fixed. So here you can see these are the small openings. So where we are going to fix the notch to the end of the canal or a channel. So this is the top view of the channel. So this is the triangular notch and this is the plate. Here you can see this is the plate and this is the triangular notch which is going to be fixed. So not only triangular notch, even the rectangle, trapezoidal and stepped notch is also fixed like this. So here some screws are going to be used to fix this notch. Whereas weir is nothing but it is also an equipment which is device used to check the rate of flow of the canal. So in case of a weir, so weirs are used, the materials which we are going to use to construct weir is masonry or a concrete. So this difference I asked you people. So notch is a thin metallic plate where weir is nothing but it is the masonry structure. It is fixed by means of screws. It is constructed inside the channel. It is fixed at the end of the channel. It is constructed inside the channel. If this is the direction of the flow of liquid, then this will become upstream side and this will become downstream side. So this is the top view. Okay. So this is the top view. So the side view, it is somewhat like this. Okay. So this is the direction of the fluid. This is the upstream side and this one is downstream side. And this portion we are going to call it as a crust or a sill. So this portion we are going to call it as a crust or a sill of a notch. And this is the crust or a sill of a weir. Crust or a sill of a weir. Okay. So this was the things which we have discussed in the yesterday's class, and also we have derived the equation for a rectangular notch. So in today's lecture, I am going to derive the equation for a triangular notch. Now think that there is a channel, open channel. So in this open channel, I am going to fix a triangular notch or a V notch. Okay. And I am going to check what is the discharge, that is flow of water through this triangular notch. So here, this is the side view. So this is the open channel and triangular notch connected or fixed at the end of the canal or a channel. So when you're going to see it in this direction, so this is the front view. So when you're going to see this portion, this triangular notch will look like this. So this is the level of the water and this is crust or a sill. So the water is overflowing this crust or a sill. So now it is very difficult to identify the discharge for this entire surface. So that's why I am going to divide this into number of strips. And I'm going to calculate what is the discharge for one strip. And when you're going to integrate that, you're going to get the discharge for the entire triangular notch. So same as we have done in the rectangular notch, same thing is carried out in a triangular notch. But thing is that in case of a rectangle, the shape of the notch was different. So here it is a triangular shape. There it was a rectangular shape. Okay. So now let us derive the equation of a triangular notch. So here you can see this is the triangular notch, level of the water. So it is very difficult to identify the discharge. So that's why I'm going to divide this particular portion into number of strips, parallel strips. And I'm going to calculate what is the discharge for this strip, for a single strip. When I'm going to integrate that, I will come to know what is the discharge for this entire triangular notch. So here, let me consider H as a head of water above the V notch. So what is H here? H is nothing but it is the head of water. So here you can see this is the head of water, capital H, head of water over the notch in the sense above the crust it is. Okay. So let me consider it as a capital H, and theta is nothing but it is the angle made by the triangular notch or a V notch. So now consider a horizontal strip of a water of a thickness dH. So I am going to take this strip. So let me take this strip, and the thickness of this strip I am going to take it as a dH, and H is nothing but it is the height of this strip from the free surface of a liquid. So now the entire angle was a theta. If you divide it, then this particular triangle, that is a right angled triangle, so the angle made by this will be theta divided by 2. So This is a triangle, triangular notch. The angle made by this notch is how much? It is equivalent to theta. Okay. So I need to identify this distance. So that's why I'm going to divide it. So when you're going to divide it, it will form a rectangular, right angled triangle. So right angled triangle. So theta divided by 2, and this angle will be theta divided by 2. Okay. So now I'm going to consider one right angled triangle, and I'm going to name it as a ACO. So suppose if I take this particular portion, are you understanding what I'm saying? Hello, you all are there or you left?
Yes,
Yes,
ma'am.
ma'am.
There,
So
ma'am.
this particular portion I have divided it because I need this distance. So therefore I am going to consider this portion. Okay. So this is that ACO. So triangle ACO, and the angle is theta divided by 2. If this is the total height h and this is the small h, that is the height of the strip, then this distance is equal to how much? This distance is equal to how much? So I have taken this here. I have taken this triangle A, C, and O. So the angle made by this right angled triangle is theta divided by 2. And if this is the total height, and small h is nothing but it is the height of the strip from the free liquid surface, then this distance is equal to how much? It is capital H minus small h. So h minus h will give you this height, this one. Okay. So now apply the rule here. So tan theta by 2 is nothing but it is AC divided by OC. Okay. AC divided by OC. So what is AC? This distance we have to identify. But what is OC? It is H minus H. So therefore I need the distance AC. Okay. So therefore AC is nothing but it is this term H minus H will go to the numerator. So that will become H minus H into tan theta divided by 2. Applying tan rule. So this particular right angle triangle is nothing but AC divided by OC. Okay, where OC is nothing but it is the height capital H minus H. So this capital H minus H I am going to take to the numerator because I have to calculate the distance AC here. Okay, so the distance AC is nothing but it is H minus H tan theta divided by 2. But what is AB? From this triangle, what is AB? What is AB here? What is AB? It is 2 times AC. Agreed with this?
Yes, ma'am.
So AB is nothing but it is 2 times AC. So therefore 2 times H minus H into tan divided by 2. So therefore the value area of the strip is nothing but it is AC plus AC, that is AB. So therefore AB is how much? It is 2 times H minus H into tan theta divided by 2 into DH. So base is how much? Base how much we have got? It is AB, which is equal to 2 into H minus H into tan theta divided by 2. So this is the base. Okay. So what is the area of the strip? How the strip is looking like? It is looking like a rectangle. Okay, suppose if you take this as a AB and this is the thickness DH. Okay, so this strip is looking like a rectangle. So the distance AB we have identified, that is nothing but 2 into h minus h into tan theta divided by 2. Okay, now what is the area of a rectangle? What is the area of a rectangle?
Length into
Length
breadth.
in
Length into breadth.
Okay, so therefore area of the strip we can write it as a 2 times h minus h into tan theta divided by 2 into this height, that is dh. Okay, this is the area of the strip. So this is only area of the strip. Now how you are going to write the dq value? CD into area of the strip multiplied by velocity, theoretical velocity. So CD will remain as it is. What is the area of the strip here? It is 2 times h minus h into tan theta divided by 2 multiplied by, what is the theoretical velocity? It is square root of 2gh. Okay, so go on equating the value here. dq is written as CD into area of the strip into theoretical velocity. So CD into area of the strip is nothing but it is 2h minus h into tan theta divided by 2 into dh multiplied by the theoretical velocity is square root of 2gh. So now take the constant terms outside. So this is 2 times CD h minus h into tan theta divided by 2 into square root of 2gh into dh. So the total discharge is identified by integrating dq. So this is nothing but it is the discharge only for this strip. We have not identified the discharge for the entire notch. We have identified only the discharge of a strip. If you want to know the discharge for the entire triangular notch, then the above equation is integrated with respect to 0 and h. So when you are going to integrate, you are going to take the common terms outside, that is constant terms. CD is constant for a triangular notch. Theta value is constant until and unless till you remove this notch, till you replace this notch with another one. Hello? So till you replace this notch with another one, the angle of the notch will remain same. So this is also a term which is constant, and square root of 2g. So square root of 2g, acceleration due to gravity is 9.81. So all the terms are taken outside, constant terms, and integrate h minus h into h. That is square root of h is nothing but it is h raised to 1 divided by 2 into dh. Understood up till here? Understood up till here?
Yes, ma'am.
So here you can see when you are going to integrate this, so this h raised to 1 by 2 will come inside the bracket. So it is written as h raised to 1 divided by 2 minus h into h raised to 1 divided by 2 is h raised to 3 divided by 2 into dh. So later this equation we are going to write it as we are going to integrate this h into h raised to 3 divided by 2 divided by 3 divided by 2 minus h raised to 5 divided by 2 whole divided by 5 divided by 2. It is 3 divided by 2 plus 1 and 1 divided by 2 plus 1 it is after integration. So equate the value of a small h as a capital H. So therefore when you are going to replace a small h by capital H, then you are going to get the equation as h into h raised to 3 divided by 2, and the denominator 3 divided by 2, if it goes to the numerator, it will become 2 divided by 3 minus again the denominator is 5 divided by 2. When it goes to the numerator, it will become 2 divided by 5 into h raised to 5 divided by 2. Here I am replacing this small h by capital H. So further take the LCM here. So 5 3s are 15. So 15 will be LCM. So 3 5s are 15, 5 3s are 15, 3 2s are 6. 6 minus how much it will be? 10 minus 4 it is 6. So 10 minus 6 will be how much? It is 4 divided by 15 into h raised to 5 divided by 2. So therefore, this 4 into 2 is equal to 8. 8 divided by 15 into CD into tan theta divided by 2 into square root of 2g into h raised to 5 divided by 2. So this is the discharge equation for a triangular notch. So this is the discharge equation for a triangular notch. So here you can see this 4 divided by 5. So 4 multiplied by 2 is 8 and this 15 is taken to the denominator. CD into tan theta divided by 2 into square root of 2g and this h raised to 5 divided by 2 will become h raised to 5 divided by 2. So this is the discharge equation for which kind of a notch it is? It is a triangular notch. So what was the discharge equation for a rectangular notch? 2/3 of CD into L into square root of 2g into h raised to how much? 3 divided by 2. Whereas the discharge equation for a triangular notch is 8 by 15 into CD into tan theta divided by 2 into square root of 2g into h raised to 5 divided by 2. So this is the difference. In case of a rectangular notch, you are going to consider the length. In case of a triangular notch, you are going to consider the angle, that is tan theta divided by 2 into square root of 2g into h raised to 5 divided by 2. So this is the discharge equation for a triangular notch. Suppose for a triangular notch or a V notch, if you take the value of a CD as a 0.6, okay, if the value of a CD is taken as a 0.6 and theta is taken as a 90 degree, okay, if you consider the V notch as a right angled, so where it was, okay, if you consider this angle as a 90 degree, if you consider theta as a 90 degree and CD value as a 0. How much? 60. So if you equate the value here, that is 8 divided by 15 into CD value, I have taken it as a 0.60 into what was the angle theta? It is 90 divided by 2, that is tan 45 into square root of 2g into h raised to 5 divided by 2. So when you are going to calculate this, the value of the terms we are going to get it as 1.417 h raised to 5 divided by 2. So the 8 by 15 CD into tan 45 degree into square root of 2g, that is 2 into 9.81. So when you're going to multiply these terms, you are going to get the value as 1.417 into h raised to 5 divided by 2. But this condition satisfies if the angle of the notch is 90 degree and the value of a CD is 0.6. Understood? If the angle is 90 degree and if the value of a CD is 0.6, then the discharge equation is taken directly as 1.417 h raised to 5 divided by 2. If the theta value is not equal to 90 degree, then the above equation, that is Q is equal to 8 divided by 15 into CD into tan theta divided by 2 into square root of 2g into h raised to 5 divided by 2 is taken. Understood up till here, my dear students?
Yes, ma'am.
Yes, ma'am.
So note down the equation for the triangular notch, and these equations are very, very important in exam point of view, because many a times the students, what they are going to do the mistake is, In spite of taking 2/3, they will take it as a 8/15. In spite of taking raised to 3 divided by 2, they will take some another value, 2 divided by 3. So please don't do these things. Okay. So the discharge equation for a rectangular is different and a triangular is different. In case of a rectangle, I am considering the length. In case of a triangular notch, I am considering the angle. Okay. So this is the difference. And apart from that, these ratios are also going to change. Okay. So this is a simple derivation. And in the examination, they are going to ask this derivation, that is discharge over a triangular notch or a weir. So mark it as a important. So many a times it is going to appear in the examination. So if you have taken the equation, then we'll solve few problems on a triangular notch. Hope you have taken the equation for a triangular notch. Hope you have taken the equation for the triangular notch.
Yes, ma'am.
Yes, take a problem. So take a problem. So here in this case, find the discharge over a triangular notch of an angle. So the value of a theta, they have given it as a 60 degree, 60 degree. When the head over the triangular notch is, that is H is 0.20 meter. And the value of a CD is taken as 0.6. Calculate the discharge for a triangular notch. So equate the value of a theta as a 60. Take H as a 0.20 and CD as a 0.6 and tell me the value of a discharge. It is a very simple problem. It is a simple problem. Solve it and tell me the answer for this.
$7.2, ma'am.
How much it is?
7.2.
Check it once. Check it once and tell me the answer for discharge. Please text your answers. Text your answers. 0.014. Okay. What is the unit, Chaitra? Chaitranjali? What is the unit for this? So the answer is 0.15. Nandita Shetty, check it once. It is not in terms of a centimeter. We are calculating discharge. Area into velocity. Suraj, the answer is correct. Nandita Shetty, check your answer. Okay, fine. So take next problem. So mark it as an important one. Water flows over a rectangular weir. Water flows over a rectangular weir. A rectangular weir 1 meter wide. 1 meter wide. 1 meter wide at a depth of 150 mm. At a depth of 150 mm, and afterwards passes through a triangular right angled weir, and afterwards passes through a triangular right angled weir. Full point. Take CD for the rectangular and triangular weir as 0.62 and 0.59 respectively, and find the depth over the triangular weir. Okay, so in this particular problem, so there are two types of weirs are there. Okay, this is a channel. So first you are going to fix a rectangular channel here, weir here, and next a triangular weir. Okay, first the water overflows the rectangle and then passes through the triangle. So the length, I mean to say the value of a length is given as a 1 meter, and the height of water in the rectangular notch. So the height of the water in the rectangular notch is how much? It is 150 mm. And length of the notch is how much? It is 1 meter. This is H. The height of rectangular weir it is. Length and height of the rectangular weir. Okay. Next, the water first it passes through the rectangular weir and then it passes through the triangular weir. Okay. So now you need to identify what is this height of a triangular weir. Okay. So now first calculate. So here they have given CD for a rectangular notch weir as a 0.62, and for triangular notch or weir it is 0.59. So you need to identify the depth over the triangular weir, that is H1. So first calculate the discharge for a rectangular weir. So what is the equation for a rectangular weir? Q is equal to 2/3 of CD into L into square root of 2G into H raised to 3 divided by 2. So equate the value of a CD as how much? 0.62. Length as 1 meter. Square root of 2 into 9.81. And the value of a H, it is in terms of a millimeter. So convert this into meter, it will be 0.15 meter. So take the value of a H as 0.15 raised to 3 divided by 2. Calculate and tell me the value of a Q in terms of a meter cube per second. So this is for a rectangle, discharge of a rectangle. What is the answer for this?
0.106 meter cube per second.
0.106 0.1063. Is there any other answers from your end? Any other answers? 0.10635. Okay. So whenever you are going to send me the answer, please write the unit, because unit is very important. If you follow this same method in the examination, you are going to do the same thing. You will forget to write the unit. Unit is very important. Even though the answer is correct, and if you have not written the unit, then you are going to get 0 marks for that. Okay, fine. So the discharge for a rectangular weir, we are going to get it as 0.1063 meter cube per second. Now tell me how you are going to calculate the head of a triangular weir. What is the equation for a triangle? Q is equal to 8 by 15 into CD. Yes, can anybody tell me the equation for a triangular weir or a notch?
Q is equal to 8 by 15 CD into tan theta by 2 into root 2 G into H raised to 5 by 2.
H raised to 5 divided by 2. So this is separate, okay? It is not taken into the square root. So now, what is the discharge here? Suppose in this example, where it was okay. So think that 0.1063 meter cube per second of liquid is passing through a rectangular weir. What will be the output? If input is this much, then what will be the output? How much quantity of water will be flowing through this triangular weir? The discharge 0.1035. Once it comes in contact with the rectangular weir, it passes through the rectangle and then passes through the triangle. Okay, if you take this as an input, what will be the output? How much it will be? How much it will be?
Oh,
So
more,
think that there is a
more
pipe.
than rectangle.
No. Think that there is a pipe and you have supplied around 0.10635 meter cube per second of water. What will be the exit? Exit discharge of water will be equal to how much? Simple question
Same
it
as
is. If you supply 0.1063 meter cube per second of water inside a pipe, at the exit, you are going to get the same amount of water. Okay. So please understand the question and tell me the answer. If you supply around 5 liters of water in a pipe, then what will be the output?
5 liter.
It is 5 liters. Why it is 5 liters? Because we have not considered any losses. If you consider loss, then it will be obviously lesser. Okay, or it may be a greater also. So therefore, we have not considered any losses. If you don't consider any loss, then input will be equal to output. Simultaneously here, in this case, we have not considered any losses. If 0.1035 meter cube per second of water is passing through the rectangular weir and then it passes through the triangular weir, then what is the discharge through this triangular weir?
Same, ma'am.
It is same. Okay. When it is same, when we have not considered any losses. Okay. So the equate the value of a Q as 0.1063, 8 divided by 15. What is the value of a CD they have given for a triangular weir? How much it is?
0.5 lakh.
0.59.
0.59.
59.
Okay, fine. And what is the angle theta? What is angle
90
theta?
degree.
Because it is a right angled where it is. Okay, it is a right angled where. So therefore equate the value of a theta as how much? As a 90 divided by 2, and this is 2 into 9.81, and I'm going to take this as a h1. So here also there is h, and if you take this as a h, same designation, so there may be chances of taking 0.15. So h1 is nothing but it is the head over the triangular notch, and h is nothing but it is the head over the rectangular notch. So h1 I don't know, keep it as it is. Now calculate this value and tell me the answer. How much it is into 0.59 multiplied by 8 divided by 15. How much you are going to get? 1.39?
Yes,
Are
ma'am.
you going to get 1.39?
Yes, ma'am.
Yes, ma'am.
Okay, this is 0.1063 equal to, what was the answer? 1.39 into h1 raised to 5 divided by 2. So now take this to the denominator, 0.1063 divided by 1.39 equal to h1 raised to 5 divided by 2. This ratio is equal to how much?
0.076.
0.0762.
0.0762.
762.
Okay, 0.0762 equal to h1 raised to 5 divided by 2. Now calculate the value of h1. h1 raised to 5 divided by 2 equal to 0.0762 it is. Now how we are going to calculate h1? If this is taken here at the right hand side, 0.0762 raised to 2 divided by 5 it is. It will become inverse. Now tell me the value of h1.
0.0152, ma'am.
Check it once.
Zero point three five
0.3.
seven.
0.03048, ma'am.
0.3.
0.03048.
0.304. Check it once. Two divided by 5 will be equal to how much?
0.4, ma'am.
0.4. Then 0.0763 raised to 0.4 will be equal to how much? 0.357. Any other answers? 0.357 meter is the answer. 0.37. How much it is? 357. 357 meter is the answer. Okay, understood? Understood this problem? Mark it as a important. Okay, take another problem as an assignment. So here I'm going to give the values. So length is 1.5 meter. Discharge, that is Q, for a rectangle. It is 200 liters per second. Next, for a triangular notch, it is a right angled notch. Right angled notch. So find the position. Find the position of the apex of the apex of the notch, of the triangular notch it is. V notch from the bed of the channel. From the bed of the channel. If the maximum depth of water is not be exceed 1 meter. Take CD as 0.62. So note down this problem and solve it by yourself. It is 1.5 meter length. So discharge through a rectangular notch is 200 liters per second, and then it passes through a right angled notch. Similar kind of a problem, but here they have twisted the problem. So just go through it and solve it. Have you taken the problem?
Yes, ma'am.
What about others? Those who are present, raise your hands. Okay, fine. This is all for today. We'll meet in the next class with the next derivation on a trapezoidal notch.